So, good afternoon. Thanks for introduction. What a crazy day. I had issues with internet connection, so my PDF version might not be the best fit, but it works, and there are slides, it's cool. And moreover, actually, have you ever had a feeling that you're attending a conference? You think that you have a day off, okay, no conference, no work today, of the duty, and your Slack or chat or mail is pinging you. Hey Robert, your project is on fire. Burn, help us. Hell no. Actually, it was me 15 minutes ago. 15 minutes ago, before this presentation, I got a Slack message that there is a project burn. Actually, my project management thought I am an attendee of the conference, not a speaker. Damn God. But actually, so I refused. I said to her that, okay, I prefer to show my presentation I've been working on, not fixing bugs. So I'm not sure if I'm going back to my work on Monday. And yeah, in case, I got a question for you. Are there any recruiters there? Because if yes, I will be in touch on Monday, since Monday actually. Yeah, but seriously, I'm kidding. I don't want to lose my job. I'm not sure if they want me back on Monday. But actually, if yes, it's okay. My real question was, honestly, really, is there anybody of you who was involved in machine learning engineers or data engineers recruitment? Somebody who was asking technical questions to candidates or something? Yeah, okay, great, thanks. Because if yes, are you sure? Okay, if yes, I'm wondering if your feelings about this recruitment is the same as mine. Because in the last 2 months, I was supposed to help in data engineering recruitments. And in my company, actually, it was a rule that data engineers are relatively close to machine learning engineers. So my first question to candidates was, do you know how machine learning team handles data, versioning, storage, etc.? Second question was, how do you handle experiments? And the answers were rather not satisfying me, actually, because the most common answer for this question is, okay, I heard about good practices, but actually it's not related to mine project because it's not standard, it's not typical. Oh, please. Okay. I have to stand right back here. Okay, so yeah, actually everybody knows about the good practices in machine learning flows, about the storage of data and the handling experiments, but as I saw, nobody uses that. And that's bad. Let's change it. Let's change it with the presentation in here. Welcome. My name is Robert Kostrzewski. I work in NetGuru company, and welcome on board. Okay, so let's go to the next slide. In the end. Okay, so I started discovering the topic last year. And I found a good quote from the guy from Google, not a random person from Google, technical lead on TensorFlow. So it's a quote, "It's so bad it sometimes feels like stepping back in time to when we coded without source control. Sounds terrible." So of course, I keep attention to DevOps, to flows, and the consistency of development, because previously I've been a backend developer, web developer for 5 years. So things like DevOps, continuous integration, and etc. was necessary for us. I went to machine learning because it was a great field to adventure, and then I saw, okay, you don't have such specific concepts, such specific flows, why not? And then I went to Google Trends, and I typed out MLOps, machine learning operations. So it is typical related to DevOps, but rather to machine learning field. And what can I see? Nowadays, the trend is high. Okay, and we can see, actually, because one of the keynotes today was sort of relevant to machine learning flow. And the second presentation in room 1 is also about some machine learning flows and good practices. But in April, it was like 25%. So not everybody was thinking about this. I am afraid of thinking what was 2 years ago. That's why we have to think about this. Okay, so let's talk about the standard project we got in, for example, backend web development. So we have these 5 steps like planning, this is an idea, then this is analysis, so we have to think how to change ideas into tasks and then into code. Then we have to design, so let's imagine that we have backend done, but we haven't frontend discussed yet, and then implementation, so the developers can have fun a bit. And then maintenance. So if we deploy the first version, we can think what should be fixed, what should be improved, and the circles goes around. Okay, but we have machine learning. So it is called in some places software development 2.0. So in standard way, we have algorithm. The developers write code, and they have some data from databases at most, and they have output as a front end and work in backend. In machine learning, we don't have algorithm per se. In strict way, we have outputs, we have data, and we want to determine the algorithm. So we have to go with some another flow. So key differences between the standard flow in backend development, for example, and machine learning development, from my point of view, they are three things. First of all, data. In backend development, we have data like, for example, 5 gigabytes of data of users would be quite large. It's not a big data yet, of course, because in machine learning, we know a lot cases that data are terabytes. There are, for example, Keras challenges with video processing from Google. It was really difficult challenge on Kaggle, just because the data volume is so big that we cannot handle that on our local machines. So we have to do something. So data is first. Secondly, experiments. So we are talking about that like we do in machine learning. So we are creating models, we are preparing experiments, we are making training, test, validation, all that stuff, and our model file is being done. Okay, but of course it's no one experiment. It's a bunch of experiments with different parameters. Who the hell would not mistake if somebody would manage that in manual way? So we have to somehow maintain the experiments we get. And then we have to deploy that, because, yeah, for example, in my first machine learning project, commercial project, I was so happy that I produced a file with model, for a machine learning model. But what else? For a client, it was nothing. Okay, he said to me, okay, you have a model, great job, but I actually don't know what to do with that. Please deploy. And if deployment is a task for one person and for one project one time, it's not a problem. Okay, you can copy the model into the, for example, iOS or Android code application, and you have everything working. But what if I have 50 iterations? We have 50 models and we have to deploy it somehow. We should think about this, how to do it in an effective way. Yeah, so let's go into updated circle of machine learning project, not backend project. So we have some other steps. We have data engineering at first. So we have to take data from client, understand them, think how to format the data into our format to, for example, CSV files, some databases, to Python, depends on the size and depends on the format of data. We have to do some data processing. Then data insights, maybe we need some data enrichment, maybe the amount of data from client is not enough, so we have to do something with that. If we got the data topic closed, we can go into pipeline. Pipeline, we have to do something in Python to convert the code from the model to the deployment. And if we have pipeline, we have first baseline model, which is the first model we got, the first results, first metrics. We are happy, but it's not the end. Actually, it's just the start of our journey. And then if we have baseline model, we have to deploy it so we can try the baseline model on real case, on real apps, for example, for beta testers. And then we have model monitoring. So we can see if our model is a final one or should we once again go around with this circle. So yeah, we have code, we have data, we have training, testing, and building process with deployment at the end. So I collected all these three into ML operations process. So we have to handle all those elements into specific positions, and we have to use the specific tools to make it in an effective way. First of all, I would like to talk about data. There are some challenges in data. First of all, it's versioning. So let's imagine I am the only one project in machine learning project. I'm the only one developer in the project. So it's okay. I remember actually what kind of data I got, what kind of versions of data I got. But if I have a team of 10 people, it's a problem for us. Because not everybody can notice any changes in data, and changes in data sets are quite common because maybe client have some new data for us, maybe we have some data indication and we added new data bunches from other sources to our previous source and make our model more rich. So yeah, subsets of data set into train, test, and validation. It's also a case where we should handle the data properly, and using only, for example, local machine is not enough. Thirdly, integrity of data among all developers. I have already covered this topic. And easy access for Python pipeline code. Actually, I am working in Python, in Pandas, and other frameworks. That's why I want to have a good, easy, and maintainable access to make data as a read data to Python and sometimes write back data from Python to some files. So I want to introduce you the first tool, which is Quilt. Quilt is a simple wrapper of AWS S3, which provides a function of data versioning tool. And I don't know how many of you knows DVC, data version control tool. If yes, it's something. It has some commons and differences. I didn't choose DVC as the topic of this talk. I focused on Quilt. So, Quilt, data versioning wrapper of AWS S3, and great for me API for Python. Okay, so Quilt does data insights, data engineering is around the data because it's a source of data we load into Python. And then it is, of course, used in baseline model creation because within the model creation, we use data to train the model. Okay, so now some examples of using Quilt. So you can create an account in Quilt. As you can see on the left top panel, it is used as S3 bucket, so we have to have some S3 bucket. And then Quilt does some data versioning for us. So it is possible to have some metadata. It is possible to have several revisions of the same file. So it is quite similar to Git for data. It's quite similar for the approach of DVC in data, but actually it's not Git related as much as DVC. It's rather cloud-based tool as a wrapper for S3. So in this case, I just explored one CSV file as my data set, and of course I can have an example, I can have a preview and some metadata with the shape, serialized data size, and other informations. We can have also, so the previous view was about the files view. This is about the packages view, because Quilt is managing data in packages. So we can see that we have Carlin's project. This is a project from NetGuru. And we have the folder package called classifier. And we have two revisions. So if I make a model, I can use the data in first revision, and then if I add additional data, I can simply switch the digest of the second revision and immediately use the new data, new bunch of data into the trained model. Okay, about AWS, I actually said a lot. You can visit open.quiltdata.com to see lots of examples, lots of open buckets for us, and you can see how Quilt helps in machine learning projects in case of data. Okay, so now a couple of screenshots about loading data. So Quilt knows that we have data in S3 bucket, and it's not a Git itself, because we can have different approaches to handling data. We can fetch the whole data set into the local machine if we are doing something locally, and it would be one command. We can also fetch single files. Sometimes we don't need the whole data set locally. Sometimes we want to revise only the one file. So this is the fetch function from Quilt. And as you can see, Quilt is a simple Python package. So we can create an instance, we can sign into the bucket we have access to, and then fetch some files to the local disk. Then Quilt in version 2, in the previous version, had a really nice syntax, because our data set, it was possible to import data sets as simple Python packages. So Quilt3 is a package name, like the library name, data, then alexc is a account name, and then hadat is a name of the package. And within the return, we have local package. This is the dictionary, so we can achieve the keys and go through the directories into specific files. Okay, and if we want to have the way to fetch all the data set, we can use quilt3.package.install. We can specify top hash, so I can use the first revision, and after a week, I can simply immediately change into the second revision. The similar is with the browse method, but it doesn't install the package itself to the local machine if it's already present there. Okay, and also as we can see, we can manage our package as a Python dict simply, so we can step between folders and achieve the files. As you can see in the second line, we have how.data Atlantic storms.csv, and we have something called package entry. It's not a content of the file yet, but we can open that with the, for example, file.open, open file. But also we can use the deserialize method, and then afterwards we can return the content of the file. So there are many strategies of handling data in Quilt, so use whatever you want. We can also setting and uploading packages. So, okay, I have some source data. I want to load it into Python, but maybe after some processing I want to, for example, send back the validation set I created, train set, some subsets. Okay, so within quilt3.package.methods, we can set metadates of the files we got in package, and we can specify the package into Quilt, and within quilt.push we can we can save the data to S3 bucket. So it's quite handy for me, I guess. Yes, this is a push, and then we can list packages. So this is quite a synchro between the packages in S3 and our local ones, if we need them. Okay, also Quilt has some support for metadata, so we can specify the author of the file, we can specify the purpose of the file. If we got some, for example, images, we can have the metadata, what kind of resources on the image. If we have audio files, which are also included into Quilt support, we can have an information about what was the date of the creation of the file, audio data, or what kind of voice is inside. So also metadata is quite useful. And Quilt versus DVC. As we can see, DVC works like Git. Quilt, not necessarily, but actually I see that DVC tool tends to work like GitHub, so we cannot share projects data between projects itself. Within Quilt, it's not a problem. We can go into a second project Python code, we can make authorization to Quilt, and we can browse and download the data sources. So it's quite handy. And example, we have a application made in NetGuru, which is CarLens. Do you know Shazam application for music? You hear the music, but you don't know the name, so you turn on Shazam and it tells you what kind of song is that. It is for cars. So you see the car on the street, you are not sure what kind of car is that. You use the phone, and within the image recognition, it is possible to specify the model of the car and other informations. And within CarLens, we used Quilt as a data sources, as a data versioning. So we can see the example that we have specified some folders with different types of images, and we have lots of different sources of data. So it was helpful for us to have Quilt because different revisions told us when the data was achieved. We had problems with the baseline model. It was really poor. So we decided to go to the city town, make a lot of photos of cars and annotate them by ourselves. That's why Quilt, versioning and revisions and metadata helped us a lot. And another example, you can see that Quilt is able to show images also. Okay, next topic, experiments. Data is not only the one concern. Experiments. So we have these experiments. We have to handle hyperparameters of experiments. Let's imagine that we have clustering. So we can have some parameters like the algorithm of clustering, number of clusters, other parameters. If we want to schedule 100 clusterings experiments, we have to somehow handle what kind of hyperparameters were stored in one experiment, what was the result, what kind of metric we wanted to find, and how it goes with the error or success. Yeah, and also infrastructure. If I want to provide 1,000 experiments, I won't do that on my local machine. I won't schedule any jobs on SSH remote machine. I want to do something better for that. And that's why I want to show you the second tool, which is Polyaxon. Polyaxon is wrapper of Kubernetes, not S3, now experiments Kubernetes. So we work with Polyaxon to schedule and maintain experiments. So as you probably know, Kubernetes is something a bit better than Docker. It has some pods, which are sets of containers. We are using in NetGuru Polyaxon like this. So we have a project. I am creating a YAML file with some rules. I want to specify 1,000 of experiments with different hyperparameters. And okay, I save a YAML file. I send it to my GitHub repository and I run Polyaxon. And I tell to him, okay, run this 1,000 experiments. So Polyaxon connects to Kubernetes. Kubernetes owns the infrastructure of how it goes, and at the the lowest level is Google Cloud Processing. So yeah, in NetGuru we use Google Cloud Processing machines. It starts. It creates a Docker container, it has some inside data, it does what it should be, so some train prediction, it returns some metrics and it turned off. And of course Kubernetes maintains all these Google Cloud Processing machines. Okay, and so Polyaxon in Flow is rather a creation of baseline model, model deployment and model monitoring, I would say. Of course, it is also visible in pipeline creation. We can have a schema that there is a Polyaxon inside. We have Kubernetes outside as the below level of the flow. We send jobs, we fetch live metrics, we fetch the final model file, so it's okay for us as a data science team. And inside, of course, in this slide is Amazon computation resources, but actually we use Google Cloud Processing for now. And Polyaxon, this is a screenshot of actually a single experiment group. So we can have this YAML file, and I specify experiment group about how many of experiments I would like to fetch at once. And if it's a clustering, I want to try clustering with some sets of parameters, another experiment with another sets of parameters, and etc. And this Polyaxon view web panel handles that all. Within this view, we can see I had 18 experiments, and all of these were successed. Okay, this is a view of single experiments, so we can see declarations, so hyperparameters, or simple parameters of the experiment. So I was doing clustering. I used K-mode's algorithm with the decomposition of UMAP. I used metric hamming. I used 50 clusters, and this is the simple single experiment. Okay, so we have Polyaxon CLI. If I have a YAML file with the specification of the experiment, I can push it to GitHub repository. Then I can run Polyaxon. I can create a link between local instance of Polyaxon project with the remote one. And if I'm after annotations, I can upload the current version of experiments into Polyaxon registry, and then I can run this YAML file. Okay. Then outputs, if everything goes well, in my Polyaxon output, we can see CSV file with results. So this is only my format of some answers. And we have two pickled files, which is model and model from transformation UMAP. We used scikit-learn, so we pickled the model, but if we had TensorFlow, it would be saved in the another format, of course. And the configuration, a YAML file inside is something like this. So we have group of experiments. I specified that the concurrency is 20, and then I have some matrix of parameters. So I want to have all possibilities, all permutations of K-mode's algorithm of clustering. I want to have experiments with 10 clusters. I want to have experiments with 20 clusters and 50 ones. And also, I can try different distant metrics between clustering. So I want to cosine metric, I want to Euclidean metric, and Hamming. Yeah. So Polyaxon, as we can see, we can calculate that we would have 1 to 3 times 1 to 3, 9 experiments. Because if some of the declarations are single entries, of course, is a 1. But Polyaxon would create 9 experiments with each set of parameters, and it schedules that in Google Cloud Processing. Okay, also we can specify the environment resources. So if I don't want to pay much to Google, I can request only a half power of CPU or GPU, and I want to specify only 1,000 of megabytes of memory, for example, and other specific options. And Polyaxon config, and the last stage is build rule. So I want to use Docker image Python 3.7 to build our container inside Google Cloud Processing machine. Build steps would be, of course, some setup scripts. And then I am doing run command. So first of all, we can see that we have some pipelines of the commands. First of all, I can link the Quilt packages. It is quite legacy code from the Quilt version 2. I have a script called extract data. And I have the Python script. So I am calling the run experiment method from source class. And I am passing all these hyperparameters from the declarations inside Python file. So it is encapsulated a bit, actually. I pass all the parameters related to the model training as a parameter of the code of the class. So with that, I can schedule lots of experiments. Okay, and the final experiment config would be visible similar. Okay, and also I can log parameters like metrics. I can log metric and parameters at first. So each experiment, Polyaxon handles logs. So on the entrance of the experiment, it has some parameters like hyperparameters and other stuff. And the last, within the training, we have to know the accuracy, recall, or something. So we can log metrics with the log metric function. And as we can see, Polyaxon also has some panel for showing the metrics for accuracy, precision, and the second one is an example for time series. Okay, I see that I'm run of time. I also specify some examples, but if you want to ask about them, feel free to eat lunch with me and ask about some examples of Polyaxon I was using in NetGuru. So thanks a lot, and if you have any questions, please come to me. Thanks.
Any question?
Thanks for the talk. Could you tell me, may I use both of these packages without any kind of cloud providers? Let's say I have my own infrastructure.
Have you used DVC before?
Yeah.
So I think the DVC has this ability to work locally.
Yeah, but they don't have these fancy panels. So.
Yeah, about the Polyaxon, I'm not sure how many methods of handling Polyaxon is. I think Polyaxon, you can use Polyaxon within some local machine. So you have your own remote server. You can set up a Polyaxon wrapper, and that's all. It's okay. About Quilt, no. Quilt in version 3 is focused on S3.
Okay. Okay. Thanks.
Thanks.
Any question?
Hi, thank you for the talk. Do you know whether this Quilt package, will have a support for Google Storage?
I actually was having a chat with the authors of Quilt. For now, they said it is their third version of Quilt tool. So previously, in the second version of Quilt, it was possible to store data rather locally. So our local instance on our local machine and some other server. Quilt 3 is focused on AWS S3. And what was told is they want to have a support for Google Cloud and for Azure from Microsoft, but not in this version, maybe in the future. Let's ask them about in half year, maybe.
Okay, thanks.
Thanks.
Hi, I've got a question about, because you said that you are using Polyaxon with Google Cloud, right? And
yes.
Quilt seems to be like more on S3. Do you use them together somehow, or is it like a part of the non-free version, or?
Yes, I use all of these tools together, as these circles I was showing on the diagram was half a Quilt, half a Polyaxon, and you can see it's rather a legacy configuration, but Polyaxon uses Quilt somehow. So if I run experiment via Polyaxon, Polyaxon has to know where the data is comes from. So we need to somehow tell Polyaxon that the Quilt is a source. We have to, of course, install Quilt Python package into Docker, which we are running on Polyaxon. And then if Quilt and Polyaxon meets each other, it's a good way to make experiments.
Thanks.
Thanks.
Any question? I don't see. Thank you.
Thanks a lot.